The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 2, Elementary Hyperbolic Geometry. Section 21, The Circle, Horocycle, Equidistant Curve. In a plane, the locus of a point, which is at a constant distance from a fixed point, is a circle. The fixed point is the center, and the constant distance the radius. A circle cuts all its radii at right angles. This follows in the limit when we consider a chord PQ which forms isosceles triangle with the two radii CP and CQ. That is, a circle is the orthogonal trajectory of a pencil of lines with a real vertex. Let the vertex go to infinity. Then the lines of the pencil become parallel, and the circle takes a limiting form which is not, as in ordinary geometry, a straight line, but is a uniform curve. This curve, a circle with infinite radius, is called a horocycle. It is the orthogonal trajectory of a pencil of parallel lines. The parallel lines, normal to the horocycle, are called radii. All horocycles are superposable. To obtain the orthogonal trajectory of a pencil of lines with ideal vertex, we proceed thus. Let AA' be the axis of the pencil, figure 27, and draw perpendiculars to AA'. Cut off equal distances MP, NQ, along these perpendiculars. Then the locus of P is again a uniform curve, which is not, as in ordinary geometry, a straight line, and the curve cuts all the perpendiculars to AA' at right angles. It is therefore the orthogonal trajectory required. From the property that the curve is equal distance from the straight line AA', it is called an equidistant curve. The complete curve consists of two branches symmetrical about the axis and also symmetrical about any line, radius, which is perpendicular to the axis. As the axis tends to infinity, the perpendiculars tend to become parallel, and the equidistant curve becomes a horocycle. We can thus pass continuously from an equidistant curve to a circle. When the axis goes to infinity, the center also appears at infinity. When the axis becomes ideal, the center becomes real. There are therefore three sorts of circles. 1. Proper circles with a real center and ideal axis. 2. Horocycles with center and axis at infinity. 3. Equidistant curves with ideal center and real axis. A straight line, or rather two coincident lines, is the limiting case of an equidistant curve when the distance vanishes.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.